gosh, this is trippy. Okay. So you'll have y'all's test on Monday and Wednesday. It's going to be broken up into two sections, a kind of a concepts portion and a kind of numerical problems question portion. So these first three questions, they're not exactly what you would see on your they're not going to exactly look like we're going to see on the test, but they're kind of more questions that would be representative of that portion. So the first one, I think, is a question that is a completely fair game, and I would expect it to be on the test, and it's to describe Newton's three laws of motion in words. So off the top of anybody's head, can anyone describe Newton's laws of motion?
So the first one is inertia, right?
I'll be honest, I don't remember the names, but I think it is.
No, but it's like every object in motion stays in motion until an unbalanced force acts on it, maybe?
Yeah, so if no force or no net force acts on a body, the motion of that object will not change. So, yeah. Let me switch this. That's definitely not why. Yeah. Something along those lines. Obviously, every person is going to have their own unique type of definition, but it's going to be somewhere along those lines. Unless a net force acts on an object, its motion will remain unchanged. Lexi, were you ever able to fix your audio?
Yes, I was.
Awesome. Whenever you can you send me your UID so that I can prove that you're here or sign you in?
Yes, I'm observing.
Oh. Okay.
Do I still need to send it to you?
No, good.
Okay.
Okay, the next part is, okay, so there's two more laws of motion. Does anybody know those off the top of their head? Okay, that is a no. So the second one is a fairly popular one, and you don't necessarily need to know it in words. You definitely need to know the equation because that's almost this entire course. And that's force is equal to the product of a body's, let's move you, body's mass and its acceleration. In And an equation, that's just simply force equals ma. You should have that in memory. You should be able to recall that at any time. That's this entire semester in a nutshell, is different ways to use force equals ma. The last one is whenever two bodies interact, the force of the bodies from each other are always equal in magnitude and opposite in direction. So in layman terms, every force has an equal and opposite I guess you can say force. So this is kind of like the interaction between normal force and weight. Earth pulls on all mass at the acceleration of g. And the thing that goes against your weight is normal force. If there was no normal force, you'd go straight to the center of the Earth every time. Actually, just in case, I need to divert that. The next part is just testing your understanding of dot and cross product. So it says, which of the following are correct, meaningful vector expressions? What is wrong with the incorrect expressions? So looking at A, says vector A dot open parentheses, vector B dot vector C close parentheses. Is that possible? Does that make sense?
I don't really know. Is
Don't
there
really
like
know.
okay, cool.
So
Because like B looks like it's possible, and then C looks possible. Maybe E,
okay,
but I've never seen like A or D.
A or D. So I'm not 100% remember everything that you said, but starting with A, it says vector, well, you already know what it says. Whenever you dot B and C together, you're dotting two vectors. What is the outcome of a dot product?
It's the scalar. Like
It's a
just in
scalar. So whenever you are trying to dot two vectors, you can only dot things that are vectors. So whenever you get this outcome, just call it like vector D, or can't really call it a vector because it's going to be a scalar. It's going to be some scalar D, and you can't dot a vector with a scalar. Dot and cross products are both vector multiplication. So it's possible to multiply D to A, but you can't dot them. So A would be incorrect. And the reason, because the outcome of B and C is a scalar, not a vector.
Okay, that makes sense.
Okay. So this one would be incorrect. Moving down to B, is B possible?
Can you take the cross product of a scalar? I don't think so.
No. So B would be incorrect for that exact same reason. B and C, whenever you dot them together, it's a scalar and not a vector, and you cannot cross a vector and a scalar. So now we'll go down to C. You're dotting vector A with B cross C. Is that possible?
I don't think so.
Why not?
Is your cross product result a vector?
Hmm.
And can you, oh yeah, wait, you can.
So
Oh.
this one is possible. Whenever you cross B and C, you'll get a vector, call it vector D. And you can dot two vectors. So this one's completely possible. D. Is D possible?
I think, yeah, right.
Exactly. So whenever you cross B and C, you're going to get a vector, and you can completely cross a vector with a vector. And then E. Can you do this?
Can you, I don't think so.
Okay.
Because you get the dot product as your scalar, and then that's a whole vector. So would you add your scalar to every vector component of A? I don't know.
No. So you can't actually add a scalar to a vector.
So
You
no.
can add vectors together, which would be exactly how you said, adding each of the components together. So you'd add all the i's together, you'd add all the j's and the k's. But you can't just add, say, like 5 to vector A. That's just not possible. So E is not actually possible. And let's double check to be sure. Yeah. So those are those. And then this last one is just kind of testing your understanding of net force. So it says the figure here shows two horizontal forces acting on a block on a frictionless floor. If a third horizontal force acts on a block, what is the magnitude of the magnitude and direction of when the block is stationary and moving to the left with constant speed of 5 meters per second?
Okay, so there's no acceleration on it, right?
I'm sorry, one more time.
There's no acceleration on it?
No.
So then you start out with your free body diagram.
Okay. So I have some block. Already says 5N and 3N. And then I have some force that's either, wait, does it say what direction? No, I have to determine that. So I have some direction that's going either to the left or the right at some magnitude. If I'm moving at constant speed, as you said, I have no acceleration. What does that mean about my forces?
They equal 0.
It means that they equal 0. So doing my sum of forces, I have a 5. Let me make my coordinate axis. 5 newtons to the right minus 3 newtons to the left. Here is going to give me 2 newtons. How am I going to make that 0?
Wait, can you?
One more time.
No, I was asking if you could repeat what you were asking.
Oh. So then sum of forces is 5 minus 3 so far. And that's going to give me 2 newtons. How am I going to make that 0?
Would you subtract 2?
Yeah. So this is
Oh, okay.
F1, F2, F3. So F3 is -2. What does that tell me about the magnitude and direction? What is the magnitude?
So then it's a magnitude of 2 going to the left.
Exactly.
Okay.
And does that change for whenever it's stationary or whenever it's moving to the left?
You said, does it change when it's
So
going
yeah,
to the left?
so we said that the magnitude and direction is 2 and to the left. Is that going to change from whenever it's stationary to whenever it's moving?
No, because we made it 0, right?
Exactly.
Okay.
Whenever you're stationary or you have constant velocity, your acceleration is 0. Just because you're moving doesn't mean that you're accelerating. So for A and B, F3 is equal to -2 newtons and the I had direction. Now this next set of questions is going to be more representative of your test on Wednesday. So is there a way for me to? There we go. If stone is catapulted, oh no. A stone is catapulted at time t equals 0 with an initial velocity of magnitude 22 meters per second and at an angle of 44 degrees above the horizontal. Neglecting air resistance, find its horizontal and vertical displacement from the catapult site at the following times after launch. And I just realized I did not copy the times. So we're going to make them up. Actually, just out of curiosity, did I put it there? No, we didn't even put it in there. Okay. So we're gonna do one. So how would I do this?
So you can set up a picture.
Okay, set up a picture. So I have some stone with an initial velocity and it travels some distance x. And that's pretty much it. So what can I do from here?
Okay, so you can use your kinematic equation, right?
Okay. So what are those?
Okay, let me let me find it.
I would highly suggest memorizing them. I guess maybe y'all might get it on the answer on the equation sheet.
I'm pretty sure he said we're gonna have a full sheet of like paper where we can write anything we want, and then
Okay.
and an equation sheet too.
Has he given y'all what's going to be on the equation sheet?
No, he hasn't given us anything.
Okay.
I don't even know. We don't even know what the format of the test, like if it's during lab, online, proctored, not. I really don't know.
I'm gonna assume that the first test is y'all's lab on Monday or Wednesday?
Ours is on Monday at 2.
So I'm gonna assume you're gonna do the first part during lab. And then he sent me an email. Exam 1 is on Monday and Wednesday and next week. That's not it. Let's put in hips. SI. Could have swear he sent me something. Maybe not. But I'm gonna assume that he's gonna give it to you on Monday, and it was my assumption that y'all are gonna get the second part on Monday and then it's due on Wednesday.
Oh, really? Because he hasn't said
That was my
anything.
assumption.
That would be kind of nice.
Thought I read that in an email, but I low-key might be hallucinating that. But anyway, kinematics. What are they?
Okay, I'm still looking for it. Oh, I found it. Okay, the first one. Final velocity is equal to initial velocity plus acceleration times time.
Okay.
Okay, and then change in x is equal to initial velocity times time plus 1/2 acceleration times time squared.
Done.
Final velocity squared is equal to initial velocity squared plus 2a delta x.
Awesome. So this is a two-dimensional motion problem. For all motion problems, I suggest setting up an X and a Y. For those of you who have been showing up to my sessions, you've seen me do this before. But it's essentially my columns are my dimensions, and then my rows are my actual, I guess, givens or important values. So for instance, I'm gonna have VF, V naught, A, X final, well, yeah, X initial, and then A, T. Okay. What do we know? Preferably from someone who hasn't spoken yet.
Acceleration.
Acceleration.
We have
Okay, which one do we know? I know Anissa isn't the only one taking this test. I'm trying.
Sorry, it's because all three of us are here, like in the same room. So
Oh, is the audio like really bad whenever one of y'all speak?
no, so I accidentally spoke into Riley's mic.
Oh.
We have initial velocity.
Okay. Do we have in the X or the Y or both? Or none?
Both.
Okay, we have it in both. So what is the initial velocity in the X?
So in the x direction, it's 22 sine theta.
So 22
then-
sine theta?
Yeah. And then in
Yeah.
your y, it's 22. Wait. I flipped that.
Mm-hmm.
Okay. So in your x, it's cosine. And then your y
Mhm.
is sine. Okay.
Then your y is going to be sine. Anything else?
Yeah, we have acceleration and time.
Okay. What do we have in the x and the y or both?
So we have time in both. And then we have acceleration in your y, which is gravity. And then you have
Okay.
0 acceleration for your x.
Oh. More specifically, I'm going to make it negative and say
I'm sorry, I have a question.
Yes.
On the test, do you think we
Hmm.
should always make our gravity negative?
Okay, so that depends. So the way that I like to explain it is that you only make gravity negative whenever it's going against your motion. And what I mean by that is the way that I like to imagine these questions is that the axis is pinned to my moving object. And you're basically going to determine gravity depending if gravity is going with your motion or against your motion. So for like the first half, from the beginning to peak, gravity is going against your motion. So gravity is going to be negative for the first half. The second half, from the peak to down, I think of my axis basically flipping, and then gravity is with my motion.
Oh, is that why sometimes you have to add the acceleration to gravity, like in a question?
Yeah. So sometimes at the end of questions, you'll just change the sign randomly, and there's a reason for it. And that's one of the reasons why, is because depending on how you set your axis depends on your outcome of the answer. So that's the way that I like to think about it, and the way that it most consecutively makes sense to me. So basically, I just make my positive y the direction my object is falling. So if it's going upwards, I make upwards positive. If it's falling downwards, I make downwards positive. Although I only do that for like catapult kind of questions. So like if it's free fall, I make downwards negative. That's just something that I do. But anyway, so we know acceleration. You said we knew time. Just for time's sake, I'm just going to start speeding through these. So time is going to be 1.1 for both. La 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 la. I just realized I put A twice. I'm going to make my initial positions 0. And I don't know my final positions, and I don't know my final velocities. So from here, I have exactly what I want. I have one thing that I don't know, and well, actually, what am I looking for again? And one thing I don't care about. So I don't care about the final velocity, and I want to know my final position. So which equation doesn't have final velocity?
The middle one?
The middle one. So I'm going to use the middle. So it's going to be, I'm going to start with horizontal. Let's see what that is. X final minus X initial equals V naught T plus 1/2 AT squared. Let me grab my calculator. About to break my head on here. Okie dokie. So let this be X. That's going to be 0. And that should be 0. So we end up with X final equals V naught T. So 22 cosine of 44 times 1.1 seconds. And that should give me 17.41-ish. And what's the units for that?
Is it meters?
Meters, yes. Awesome. Okay, so the next part is to do the vertical. So how do you do that?
So you said to answer like max height?
No, so I want, it's not necessarily max height. I just want to know the height at 1.1.
Oh. Oh, at 1.1 specifically?
Yeah, so at 1.1 seconds, what is my vertical height?
You can use your middle equation.
You can still use your middle equation. So I'm a y final minus y initial equals v naught t plus 1/2 at squared. My initial position is 0. And I believe that's the only thing that actually cancels. So we're gonna get y final is equivalent to 22 sine of 44 times 1.1 plus 1/2 negative 9.8 1.1 squared. Plugging that into a calculator. I get 10.88 seconds. Oh, wait, not seconds. What is it?
Meters.
Meters. And I'm gonna go ahead and stick with that. I'm not gonna do like a crazy amount of times. Once you know how to do one of them, you basically know how to do them all. Just out of curiosity, instead of it asking for my vertical, so like some arbitrary vertical height, what if it asked me for the time it took to reach its highest peak? How would I have done that?
So you could set your final velocity to 0 for that first equation.
Mm-hmm. So exactly, I would take my final velocity and make the vertical one specifically equal 0. And then, yeah, use this equation and solve for t. Any questions on how I did any of this? I know this was on your homework, and this is one of the questions you'll ask me about, right? I don't know if what I did is different from what I told y'all and didn't work, but this should be how you solve it. And if not, y'all should get a ton of like partial credit, because the only thing I would imagine you messing up is like a calculator input. So the next part says, in the figure, block A and B have weight of 58 newtons and 31 newtons respectively. Determine the minimum weight of block C to keep A from sliding. If mu s between A and the table is 0.2. So let's just start at 8. So it says determine the minimum weight of block C to keep A from sliding. So how do I do that?
So you can draw your free body, right? And then start doing the
Free
forces.
body. So let's start with A. Let's do this. What forces are acting on A?
So you have normal force, well, weight, normal force. You also have C, and then friction.
Okay. So you said weight. So I'm gonna put A. You said normal force. Did you say tension?
Riley said tension.
Then you said friction. I know you said that. What type of friction is it?
It's static, right?
Static friction. Okay. So you did mention weight of C. So I'm gonna go ahead and make this bottom weight the weight of A and C. And then the normal force is gonna be the same thing, the normal force of A and C. Let's go ahead and do block C. And what is that gonna look like?
It should be weight and then normal force.
Weight, normal force? No. 이거보다 중요하다. The normal force. And let's do block B. Let's make it a little bit further down. What is that going to look like?
We have weight and tension.
Weight and tension. Oh, shoot. Okay. I'm going to speed through some of this a little bit. So, I know that I'm not moving because I have static friction. So what I'm going to do is make all of my calculations from respect to the A block. So the sum of forces in Y is normal force of A plus C. Then we have the weight of A plus C. That's about it. Let's go on to X. So I have static friction. Then I have tension. Now, I've done a question like this in my session. So whenever you have a pulley and you have like a block dangling down, what I like to do is essentially think of the rope as a Velcro and just ignore the rope. So these two tensions are going to cancel, but this weight is not. It's still going to be going downward, but with respect to A, it's just going to be pulling it rightward. So that's just going to be plus. So instead of this tension, I'm going to have a plus weight of B. And then for A, that should be good. And A is what I care about right now. Since I'm not moving, both X and Y are 0. So that means that normal force, A plus C, is equivalent to the weight of A plus C, and that the weight of B is equivalent to the static friction of, static friction. I'm going to write the equation for weight, which is just mass times gravity. So the normal force of A plus C is equivalent to gravity, which I'm going to make I guess positive. And then MA plus MC. Yeah. Next, I'm gonna go over here. So WB what's it looking for? Determine the minimum weight of block C. So equals, what is the equation for static friction? Or friction?
It's just normal force times mu.
Exactly. So it's normal force. In my case, it's gonna be A plus C because I'm looking at block A. And that's the normal force on block A. Times the static friction, or coefficient of static friction, mu. I'm going to plug this in for N. So I'm going to move this down. Equivalent to GMA plus MC times mu of S. Do I know the weight of block B? Yes. Do I know mu of S? Yes. Do I know the mass of block A? Yes. It doesn't tell me in the question, but I can figure it out by dividing 58 by gravity. So I can figure out mass of A. Do I know what gravity is? Yes. So I know everything and I have what I need to solve for MC. So just by doing some algebra, I'm gonna WB divided by G mu S equals MA plus MC. And then I'm going to subtract MA. So this is going to turn into equals. And like I said, we can solve for MA equivalent to A divided by gravity. I can put that in, so WA divided by G. And from there, it's just a calculator problem. Putting that all in, we get I got 23.67. Am I done though?
Oh, so it's asking if it's lifted, like, there's a second part of the question, right?
No, so part A, what does it ask for?
It asks the minimum weight. Oh, so that's your mass?
Yeah, exactly. Weight is not mass. How do I turn it into weight?
You multiply it by gravity?
Yep. So multiplying it by 9.8, it's going to be around 232-ish. Yeah. Oh, wow. 232. Is that really it? Normal force. I know what I just realized. I put in 58 for the block of B whenever it's definitely not 58. Not the only mistake I made. Yeah, I think that's it. Yeah, so those are like 9.8. Oh, they're around 9.9. I think it's about 9.7. So part B asks for block C suddenly is lifted off of A. What is the acceleration of block A if the kinetic friction between A and the block is 0.15? So I don't have a ton of room, so I'm going to awesome. This is really what I need. So okay. How do I do part B?
Can you do your sum of all forces of block A and B together?
I suppose I could. So sum of forces. I'm gonna still break it up in X and Y. So yeah, still kind of using the same concept of eliminating the tensions. F of X is gonna be the weight of B minus, in this case, it's gonna turn into kinetic friction instead of static. And then Y is going to look like what am I looking for again? B? Block C suddenly is lifted off of A. What is the acceleration of block A? Oh. Okay. Okay. Yeah.
So
So normal force.
would the acceleration of B be the same thing as A, right? Or no?
I want to say yes, but I can't confidently say yes. But my assumption would be yes, they would be the same. So plus C, and then minus weight of A plus C. Okay. Similar concept for Y at least. It's so we're not moving in the Y for A. But for X, we are. So we can't just say that it's 0. So I'm going to go ahead and replace this summation with mass times A, I guess in the X, equals WB minus kinetic friction, okay. And then this I can rearrange the weight A plus C is equivalent to N of A plus C. The normal force still going to be, oh wait, we don't have C anymore. So normal force of A is just the weight of block A. I'm just gonna leave it like that. So MAX is equivalent to weight of B minus the equation for friction is normal force times mu, so it would be the weight of A times mu K. For M, what is M gonna be?
It's the 58 divided by G, right?
That's part of it. So M is actually gonna be A and B. Because essentially what I did whenever I combined the two blocks is that I turned my free body diagram to look something like this. So A, B, weight of B, friction, okay. And then you can think normal force is just gonna be of A.
Okay.
And that'd be
So
it. Well, I
then,
mean,
so
Hmm.
can you add 58 plus 31 and then divide that by 9.8, or would you have to do it individually?
you can combine them and then divide.
Okay.
So AX equal to WB minus WA mu K of WA plus WB divided by G. And again, plug it in your calculator and get an answer. I believe you should get somewhere around 2.3. Okie dokie. So let's try and see how far we can get. A car weighing 10.7 kilonewtons is traveling at 13.4 meters per second without negative lift attempts to round an unbanked curve with a radius of 61 meters. Starting with A, what magnitude of the frictional force on the tires is required to keep the car in a circular path? Okay. So, I'm gonna speed through this. 10.7 kilonewtons or 10.7 times 10 to the third newtons. The mass of the car is equivalent to that divided by G. I get 1091.84. That's going to be in kilograms. I know radius is equivalent to 61 meters, and the velocity is 13.4 meters per second. And it's going to have AC. Okay. In this case, I'm going to think of friction as the centripetal force making it go in a circle. So kind of looking at it from, I guess, like a rear view perspective. Friction, and then and then it's going forward. So sum of forces in the X is going to be simply friction. I'm just going to go ahead for simplicity, make it positive. Friction is equivalent to, well, I guess it's going to be mass times acceleration. What is my mass?
Is it the 10.91.84?
Yes. So that's my mass. What is my A? Let me ask, what causes things to move in a circle?
Oh, it's your centripetal force.
Centripetal. What is the equation for centripetal A?
V squared over R.
Yes. V squared over R. Do I know V?
Yeah, you have the
Yeah. I know V, I know R, and I know M. Plugging that all in. Okay. Times 13.4 squared, divide that by 61. I get 3213.94. What is that unit of?
Is it meters per? I don't know.
It's newtons. Friction is still a force. And if you wanted to, you could also rewrite this in 3.21 kilonewtons, or 3.21 times 10 to the 3 newtons. I think it was yesterday in class whenever he said some people were making the mistake of putting 3.21 times 10 to the 3 kilonewtons. Can anybody tell me why you can't do that?
Wouldn't that be 10/3 to twice?
Yeah. So kilo, the prefix kilo means times 10 to the third. So if you were to do that, you'd make it times 10 to the 6, which is mega. They can do this or this, but not both. The next part asks for if the coefficient of static friction, well, I guess it would be static. That makes sense. Between the tires and the road is 0.35. Is the attempt at taking the curve successful? So what I'm going to do is going to make this 3.21 times 10 to the third newtons equal to the equation of friction, which is mu s normal force. It just gave me my mu, so I'm going to get gave me F or mu S. Normal force is equivalent to my weight, which is equivalent to 10, no, 10.7 times 10 to the third newton. Okay, so what I'm going to do is multiply my normal force times my given mu. So that 10.7 times 10 to the third. So 0.7 times 10 to the third times 0.35. Does mu have units?
No, it doesn't.
It does not. And that's going to give me 3,745 newtons. What do I know about these two numbers?
What was the question? Sorry.
So question B is, if the coefficient of static friction is 0.35, is the attempt at taking the curve successful? And I'm saying, is this number that we calculated equal to this? What we got in part A.
We're not really sure.
Okay, so I'm a little concerned. Is 3,745 equal to 3,213.94?
I couldn't tell if that was a 7 or a 2, but no, those are not
Oh.
equal.
Yeah, 3.21 times 10 to the third. Probably put like a line through it or something. Are those the same number?
No.
No, they're not. Okay. Is the number that we calculated for greater than or less than? This is like second grade math, so I really hope y'all know what this is. Is this number that we just calculated greater than, equal to, or less than the number that we calculated in part A?
It's greater than.
It's greater than. So in part A, we were asked to find the magnitude frictional force on the tires that is required to keep the car in a circular path. So since my number is greater, will it be able to do that?
Yes.
Yes. So in part A, we basically solved for the minimum requirement of force required to keep it in a circular motion. Now, our force is a little bit greater, but it will travel in a circular path. It might not travel that same path with that same radius, but it will travel a path that is circular. Now, if it was less than though, it wouldn't. So basically what would happen is if it was less than this number that we got earlier, it would basically go into this bank and skid off, keep on going, and not go into that circular path. Now, of course, it's possible to have your tires to be too like sticky and kind of just like topple over, but we're assuming the perfect world where that does not happen. So less than is not good, equal to or greater than is perfectly fine. So the question of part B would be yes, and then this was part A. Moving on. Okay. Did anything in that question not make sense? Did I do something that went too fast, or did I skip a step that didn't make sense?
No, it all made sense.
Awesome. Okay. So a dated box of dates of mass 5 kilograms is sent sliding up a frictionless ramp at an angle of theta to the horizontal. Figure 5-41 gives a S. What? Is that really what it said? Gives a S as function of time. The component Vx of the box velocity along the x-axis that extends directly up the ramp. What is the magnitude of the normal force on the box from the ramp? Figure gives a real quick. I'm pretty sure that's not what it said. Gives gives as a function of time, comma, the component. Okay. Now I know. Okay. So this is a function of time of your velocity in the x. What is the magnitude of the normal force? Okay. I am caught up. So in a picture, what this is gonna look like. Hijo de la chingada. Theta. And then I have this, I guess, box. I'm gonna have a normal force. I'm gonna have a weight. And then let me put weight down here. And then it's gonna be broken up into X and Y. I'm gonna go ahead and set my axis along the ramp. How am I gonna solve for what is the magnitude of the how am I gonna solve for normal force?
Set up the sum of forces.
Sum of forces, okay. So back to white. So I'm gonna go ahead and set up X and set up Y. In the X, I have, it says frictionless, which is kind of confusing because I don't see how it's moving up. So it'd just be the weight and the x, which would be negative. And then in the y, I have normal force minus the weight and the y. Anybody see anything else I don't see?
Wait, would you use a component, like the component of weights?
Yeah. So this sub x is just telling me that this is my x component of weight, and this is telling me that it's my y component of weight.
Okay.
So I'm not going to care about the x. I'm going to care about the y, because what I'm solving for is normal force. Wait a minute. Oh. I guess I kind of do need x. Well, maybe not. Okay. Okay, now I'm a little confused. So this is a function in the x. I'm not moving in the y. So normal force is equivalent to weight in the y. Oh. Okay, normal force. Do I know what weight is?
Yes.
What is it?
It's gonna be that 5 times G.
Okay, 5 times g. And then what am I gonna do to make it in the y direction?
Would you do the sine?
Sine?
No, cosine.
Cosine. And it's be cosine of that given angle theta. Well, I guess not really given. What on earth? I don't know what theta is. I know g, and there's really not a good point. I guess I'll just round to about 3.5-ish. Okay. Okay. So I wasn't actually able to solve for normal force until I knew theta. So looking at the x, I only have weight. I'm gonna go ahead just for simplicity. Yeah, just for simplicity, I'm gonna make downwards positive. So going down the ramp is positive. And I'm gonna make sine of theta equal to ax over g. I solved for this ax by looking at this graph. There's not a really good 2 points to pick, so I kind of just guesstimated that this point is about 3.5 on the y, or negative 3.5 on the y, and use this point as my initial. So 4, 0, and then negative 3.5. It's going to give me a slope of negative 2.5, which makes sense because the only force that I have in the x is my weight, which is going to make it accelerate. So plugging that in for my sum of forces, force is equal to ma, which is going to be m times the a and the x, which is going to be equivalent to my weight. And then I can use inverse sine on both sides to solve for theta. Theta is going to be equivalent to sine inverse of negative 2.5 divided by 9.8. That's going to give me a theta of approximately negative 14.77. I'm using this, I can plug that back into here. So the normal force is going to be equivalent to 9.8. I really messed that one up. Cosine of negative 14 equal to 14.77. And that's going to give me about 47.4. That was a lot more confusing than I thought. Did that make sense? I know I went like silent there for a long bit.
That made sense.
Okay. Basically, the trick was just understanding that this graph is going to give me my acceleration. It could have given you better points, but it's still completely fine. Using that in order to solve for theta, which wasn't exactly clear in the beginning, and using that to finish off the y. Next is everybody's favorite topic, and that's relative motion. So two highways intersect as shown in the figure below. At the instant shown, the police car P is distant D equal to 800 meters from the intersection and moving at a speed of Vp equal to 80 kilometers per hour. The motorist M is at a distance dm equal to 600 meters from the intersection and moving at a speed of Vm equals 60 kilometers per hour. In unit vector notation, what is the velocity of the motorist with respect to the police car? So no, then okay. What I am going to do, it says it wants a unit vector notation. Unit vector. If I'm not mistaken. Okay, yeah. I'm gonna go ahead and set up all of my velocities to be in unit vector notation. So that's gonna look like VP is, so I'm gonna make my, so this is already has my axis set up. So VP is 0 I hat minus 80 km per hour J hat. And I will high key flip that. I hat, that's not an I, plus 0 J hat. And then VM is gonna be 6, 0 I hat minus 60 kilometers per hour J hat. With that, it says the velocity of the motorist with respect to the police. So I am in the police car and I want to know the velocity of this motorist. So this is my coordinate axis and this is my prime observer. I'm going to do that method that I taught y'all. So basically I start with where I'm at and then I follow the vectors to where I want to go. So my VP is going this way and my VM is actually going this way, but I want to go to him. So I'm just going to multiply VM times -1. So the velocity of the motorist with respect to the police car is equivalent to that doesn't make sense. VP minus VM. I'm gonna go with that and see what happens. So that's gonna be -80 kilometers per hour minus 0 I hat plus 0 minus -60 kilometers per hour J hat. So it's gonna give me VMP equivalent to negative 80 kilometers per hour. I hat plus 60 kilometers per switch to white. Okay, go to red. Kilometers per hour J hat. Let me see. So looking at that, if I'm at the motorist or I'm at the police car, the motorist looks like he's going in the negative I hat and the positive Y hat or J hat. Does that make sense?
Yeah,
That was
that
a
makes
me
sense.
question. So if I'm in the police car, I think that makes sense.
So are you just essentially adding vectors?
Yeah. I don't know why that doesn't make sense to me. I feel like it should be the other way around. Because if I were to say this way, okay, that is what I had. Yeah, that would have to be how that would be. Because EP. Right, okay. So, gosh darn it. I had it in my head and now I lost it. Oh. I can't 100% tell you why, but I know that this is right. So the velocity of MP, which is the velocity of the motorist with respect to police car, is going to be the velocity of the motorist with minus VP. So I guess I just set it up the wrong direction. So start with where you're going and then go back. Which would be the motorist minus the police car. Does that make sense?
Yes.
Okay. For the instant shown, what is the angle between the velocity found in the line? I skipped a question. No, I didn't. For the instant shown, what is the angle between the velocity found in the A and the line of straight between the two cars? So out here. What is the angle between the velocity found, which is this? Would it not be 0? Yeah, it'd be 0. Anybody tell me why?
So would you use that to find your theta?
Not exactly. So what I would do, well, I guess the good way to do it would be set up your R. What would be the R from, say, what would it be? This is 800. This is 600. So what would be the R from this car to this car? Use these. And you can do vector notation. I start, this isn't going to be my 0. And how do I use these vectors to point it to that car?
Would you use tangent
No.
or
Don't even
inverse
think
tangent?
about trig yet.
I have a question. What does
So
the R stand for? Is it reference?
R means position. That's what's most commonly used. Some people use X. But R is what's most common. So the R from this car to this car is going to be represented as 800 meters I hat minus 600 meters J hat. Does that make sense?
Yeah, and it's a minus because it's going down, right? Or he's going down.
Exactly. So looking at these two vectors, what do you see about them?
Wait, what do you mean by that?
So look at this one. What direction is it pointing? On the XY axis, what is it pointing? You don't have to be like specific, like angle, but like just in the general direction, where is it going?
Would I say, would
Okay,
you say southeast?
yes. So you can say southeast. It's going in the positive X and the negative Y. What is this one going in? What direction is this one going in?
The same.
The same direction. And looking at the numbers, they're only different in a factor of 10. So R, at least in like magnitude, is equivalent to 10V. They're going in the exact same direction. So YX, R is going out like this, and V is going in the exact same, just a little bit shorter. The angle between those vectors is 0. And if you had wanted to use trig, you could just, for R, that's the 800, that's the 600. And then solve for that theta. And then do the exact same thing for R. And you'll notice that they have the exact same angle. Does that make sense?
Yes, that makes sense. Is that always going to happen, or is it just in this case?
It was just in this case. There are obviously going to be times where like they aren't just that set up pretty. So what I would do, so I would just kind of set up the position vector and the V or whatever other vector, and kind of visualize it on an XY plane. Where is, say, vector A gonna go? And then where is vector B gonna go? And just kind of use whatever you solve for your X and your Y. And what you could do is just solve for the thetas respectively. And subtract them. And what else could you do? You could probably add the vectors and then solve for the angle of that particular vector. And that'll probably give the right answer too. Does that make sense?
Yes, that makes sense.
Awesome. Okay. Awesome. So 10 minutes and we're tuned to our last one. Can I delete this one? Maybe not. Okay. Go back. Okay. Last question. A rifle is aimed horizontally at a target 30 meters away. The bullet hits the target 1.9 centimeters below the aiming point. What are the bullet time of flight, the speed of it emerges the rifle? So let's start with A. La, 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 la. Setting up this picture. I'll do this. And then the actual flight. How am I going to solve this?
So you have to break it up into your x and y components.
X and Y components. VF, V naught, R initial, R final, A and T. Gosh, I fell back where I was going to watch this recording. Okay. What do I know?
So you know your horizontal distance. And
I know horizontal distance. So I'm going to go ahead and make my initial 0. What is my horizontal final distance?
is it 30?
It is 30. What else?
You have an initial velocity
Mm-hmm.
in the x direction. Wait, never mind.
Yeah. So anything else I know?
Yeah, you know your acceleration. Well, you know that
Acceleration.
0 is gravity for y and then 0 for a.
Mhm. And then do I know my vertical distance?
Is it that 1.9 centimeters?
1.9 centimeters. That looks like about it. I don't think we know initial velocity, and I don't think we know time. Well, we obviously don't know time. We're trying to solve for it. How am I going to do this?
Kinematics.
Kinematics. I'm going to go ahead and just write them all out. So V naught, nope. Final equals V naught plus AT. Delta X is equivalent to V naught T plus 1/2 AT squared. VF squared is equivalent to V naught squared plus 2A delta X. Okay. I know obviously that this thing has to have an initial velocity. I just don't know what it is. But I do know one thing. This thing was aimed strictly in the horizontal. So whatever initial velocity I did have is going to be all in the X. So my initial velocity for Y is 0. And knowing that, I can solve for time using my Y components. I don't care about my final velocity, and I'm looking for time. What equation is that?
The second one?
The second one, exactly. So Y final minus Y initial this is gonna go to 0 plus 1/2 AT squared. So, and also this is 0. It went from 0 to 1.9. So I'm gonna go ahead and write that as a negative 1.9. Centi, does anybody know the scientific notation for centi?
Is it -2?
So times 10 to the -2 equals 1/2 negative g t squared. So negative 1.9 times 10 to the -2, gonna multiply the 2 over, divide by negative 9.8 equals t squared. T is gonna be equivalent to just root of 2 times 1.9 times 10 to the -2, divide that by 9.8. Whenever you take a square root, there's two answers, a positive and a negative, but with time, I obviously want the positive. As far as we know, there's no going backwards in time. After you put that in, you should get somewhere along the lines of 6.2 times 10 to the -2 seconds. Now B asks for the speed as it emerges from the rifle. So that's basically my initial velocity. Well, time isn't split into 2 dimensions. Time is the exact same for x as it is y. So 6.2 times 10 to the -2 seconds. 6.2 times 10 to the -2 seconds. And I can solve for my initial velocity. I don't care about final, and I want initial. Which equation is that?
Are you asking a question? I'm sorry.
Yeah, so which equation am I going to use to solve for my initial velocity if I don't care about time? I mean, final velocity.
Would it be the second one again?
It sure would. So x final minus x initial is equivalent to v naught t plus 1/2 a t squared. 0. X final minus 1/2 a t squared. Then I'm going to divide by t is equivalent to my initial velocity. And I don't have to care about y either because I know that my initial velocity was all in the x. So v naught is equivalent to 30 meters minus 1/2. That's all going to be 0. Oh no. Divide by my time. You should get something along the lines of 4.8 times 10 to the 2 meters per second. And we're just over to 8 o'clock. Minus that relative motion question, did most of this make sense?
Yeah, it made sense. It's just kinematics, right? That's all.
Yeah. I wanted to focus a lot on motion problems, as I think those are probably the most heavily tested and probably some of the most confusing. I wouldn't spend so much time studying questions like these. I wanted to put it in just because I know they're difficult. As you can see, I still struggle with these, and I've been doing this for a couple years now. If you have a question like this, it's gonna be like one, and it's probably not gonna be this hard. If I was to like study for this test, this is probably a subject that I would not struggle, or not, I wouldn't focus too much time on this one. I would focus a lot of time on circular motion, forces, 1-2-dimensional motion, like kinematic problems. And that's what I would focus on. If you have time and you feel like you're strong on those subjects, maybe focus some, maybe 2-ish, 3-ish questions and see if you can practice some of these. But if you're like busy, I assume this is a topic that if you're gonna drop one, I wouldn't spend that much time on this type of question. Forces, motion, circular motion. I would say if he's gonna test heavy on any subject, it would be those three. Know your kinematic equations, know how to use force equals ma, know how to break forces into components, and centripetal force, centripetal acceleration. Other than that, that would be my best advice. If you're gonna study, I would focus on those three topics and work a lot of problems.
Okay, great.
I
Thank
would
you.
not, no problem. I would not like lose sleep over your concepts portion. That part of the test is one, not gonna make up a lot of your grade. And then two, it's usually not that difficult. You can usually guess your way through it or like logic your way through it. What's gonna be difficult and what's gonna make up most of your test is this portion. So all of these questions where you have to do a bunch of math and stuff, this is what he's gonna really test you on. So don't really worry about like that stuff I did in the very beginning. If you don't know for sure, kind of just know what you kind of know and put it down. I don't really know what he's gonna do for this section. I've never SI'd for him and I've never had a class with him. Usually they're like, what are unit, or like what are the units for something, or know your Newton's law of motions.
Do you think we're gonna get Marvel's test?
I mean, even if you do, I imagine it's gonna be Hibbs's test because y'all are in his class. What might happen is he might proctor a test, but he shouldn't give you the test that he's gonna give for his class, because I can guarantee you y'all are in different spots in this class. I'm sure he's already going over energy by now, and y'all are still at forces. So don't worry about Marble. If y'all see him, it's probably just because he's proctoring. Do y'all
Okay,
have
no.
any questions?
No, you just said you were gonna post this session with the worked out examples on
Yes.
YouTube, or was it your website?
So the video I can have posted by today, I don't have access to a printer, so I haven't actually been able to print this out and work it out. That's why I've been kind of fumbling throughout this session. But I can probably have it posted by the end of tomorrow.
Okay, great. Thank you.
No problem. Any other questions? Okay, you'll have my email. If you have any questions before the test, feel free to ask. You'll have the weekend. Once Monday hits, I cannot answer really any questions about the test. So don't try. If y'all send me emails with questions, I'm gonna assume it's on the test and just not answer it. I'm still not 100% sure if I'm gonna have a session on Tuesday. I will email y'all if I do, but don't expect one. And with that, I mean, if y'all have no more questions, y'all are free to go.
Okay, thank you.
No problem.